With smoke. Have you gathered that already? Even if you're in the tallest building in the world, you're nowhere near the height of Mount Everest. And even if you've reached the peak of Everest somehow without becoming a memory in your family's minds, it's still nowhere near the distance between the Earth's surface and the International Space Station. And even if you've managed to receive the qualifications you need to get into the ISS, it's still the combined diameter of every planet in the solar system plus Pluto from the moon. And even if you've been the lucky person to reach the moon, well done, because you're one of the now 13 people that have walked on the moon, and 2, you're still an estimated another cramped solar system, plus more from the Earth's sphere of influence, which is the oblate spheroid-shaped region around a celestial body where the primary gravitational influence on an orbiting body is that body. Don't worry, I didn't understand that first either, but at this point, we're only just left Earth's sphere of influence. The entire system leading to the end of the Kuiper Belt is around 287.46 billion kilometers. To put that into perspective somehow, Mount Everest, the tallest mountain in the world from ground level, is 8,849 meters in height, or basically 8.9 kilometers, or just 9 kilometers. You would need around 32,485,026.6 rounded to one decimal place Mount Everest to cover the diameter of the solar system. Scientists have only identified over 1 million asteroids in our solar system. It doesn't seem like much until you compare it to the number of words in the average book, which is between 70,000 and 120,000. Fun fact, that is just our solar system. There are over 100 to 200 billion solar systems on our galaxy alone. Doesn't sound realistic. Well, the known size of the average solar system is unknown, but taking that ours is the average, using that and using the Hill sphere of the Sun, which is 1 light year across, or 9.461 times 10 to the power of 12 kilometers, it takes a year for light to go end to end of the Sun's Hill sphere, and that the diameter of the Milky Way is 105,700 of those light years, or 9.999992 e plus 17 kilometers, and you can fit 105,700 solar systems end to end on the longest point in the solar system. Well, that doesn't make sense. How can that happen? Short answer, I do not know. But to put things into place, it takes the fastest thing in existence, the length of modern humans, to traverse the galaxy twice. That is the Milky Way, one of trillions of galaxies in the universe, and the universe is 90 billion light years in diameter. And no, I'm not calculating that in kilometers. The observable universe is finite in that it hasn't existed forever. It extends, well, obviously, 45 billion light years in every direction from us. While our universe is 13.8 billion years old, the observable universe reaches further since the universe is expanding quicker than time, I guess. But here's to confuse you, or symmetry breaking. In the early universe, pressures and temperature prevented the permanent establishment of elementary particles. Even quarks and leptons were unable to form stable objects until the universe was cooled beyond the supergravity phase. Though the system as a whole is symmetric, it is never encountered with this symmetry, but only one specific asymmetric state. Hence, the symmetry is said to be spontaneously broken in that theory. And according to the standard Big Bang model of cosmology, time began together with the universe in a singularity approximately 14 billion years ago. So what happened before time? Time is a prime conflict between relativity and quantum mechanics, measured and malleable in relativity while assumed as background, and not as observable in quantum mechanics. Too many physicists, while we experience time as psychologically real, time is not fundamentally real. According to theoretical physicist Carlo Rovelli, Time is an illusion. Our naive perception of its flow doesn't correspond to physical reality. He posits that reality is just a complex network of events onto which we project sequences of past, present and future. Einstein showed that time and space are intimately linked and that the progression of time is relative, not absolute. Although there is nothing in physics that says time must flow in a certain direction, scientists genuinely agree that time is a very real property of the universe. Also, in short, space-time will contain the entire history of reality, with each past, present or future event occupying a clearly determined place in it, from the very beginning and forever. The past would therefore still exist, just as the future already exists, but somewhere other than where we are now present. We all measure our experience of space-time differently. That's because space-time isn't flat, it's curved. Yay. And it can be warped by matter and energy. And for astronauts on the ISS, that means they get to age just a tiny bit slower than people on Earth. That's because of time dilation effects. And to sum absolutely everything up, probably none of this made sense, and we are the size of an atom compared to space. Well, yeah. Things are smaller than we think. That's the end of the video, people. If you enjoyed, it'd be greatly appreciated if you watch some more videos and maybe subscribe. It's free to unsubscribe as it is to subscribe, so if you've subbed, don't like my videos, you can always unsub. Anyway, I've been Forever Stranger, and this was episode 4 of Slytherin Society.